Okay. So we want to show by contradiction that if we have a polygon and we took the angle bisectors and made these triangles, so we're trying to show it covers all the points of the polygon. So let's suppose there's a point which isn't covered by this polygon, okay? And so so this is an incorrect proof, right? You have to figure out what's wrong with it. One more assumption that we have. So we have a point that's not covered by any of the triangles, okay?
What?
Oh, and we're gonna lead to a contradiction, okay? One more assumption that we have is basically if we have a point that's not covered by any of the triangles, you actually have a region of points that's not covered by any of the triangles, and you can find a point that isn't covered and also doesn't lie on any of the angle bisectors. Does that make sense?
Can you?
So what I'm saying is, like you can't just miss one point, okay? If you miss one, you can't just miss like one point. You always miss like infinitely many points at once. Okay. There's no way to miss just one point. Does that make sense?
Yeah.
That's kind of what it's saying.
How big is that point? It's like a very microscopic.
Yeah, a point is meant to be infinitely small. Like it has no size at all. Okay.
What?
Yeah, that's the nature of a point. So, like you can't like to miss one point is actually pretty crazy. Um,
How do you miss one point?
you can't. So that's what I'm saying. So you always have enough points that if you miss one point, then you can assume that that point does not lie on like the angle bisectors.
What if it's like so close?
I mean, it can be close, but it's just not on. Okay.
Well,
Okay. So that's an assumption. So the argument is there's nothing wrong with this assumption in the argument. Okay. You can assume that's not the problem. Okay.
there has to be inside triangles.
So basically, what we got assume there is a point in the polygon that is not in any triangle, okay? Made by the angle bisectors.
Does a point not have any dimensions?
Yeah, points are dimensionless, so it's like the dimension of a point is 0.
How?
Yeah, so if you had a length, that'd be dimension 1. You got an area, that's dimension 2. Volume,
Yeah,
dimension 3,
a,
yeah?
a dot is zero-dimensional, a line is one-dimensional,
Yeah.
a square is two-dimensional, and then real life stuff is three-dimensional.
Yeah, so and we're assuming and that this point does not lie on any angle bisector. Does that make sense?
The fact that a point is zero-dimensional is hard to wrap my brain around.
Yeah, I mean these are like so the idea of a point is like
Doesn't mean you can't have a point in real life. Like, I mean, literally have a point.
yeah, I guess the point is more like an idea, yeah? It's a simple idea. You could
Then,
approximate a point in real life. So the point approximates real life things, yeah?
Yeah.
Yeah, it's one of those notions that's like have you heard of axioms or like primitive notions? They're like it's like a basic notion. It's like if you looked up in the dictionary of like some words, it would have to go back to other words. There's no more basic words than points.
So basically, points are the building blocks.
Yeah, points are the most basic. Okay, we're kind of hanging too long on this, but It is interesting. So what I want to say is, um, the okay, so we got this point, okay? Let me make it red, okay? Yeah. And what we do is we draw a line from the point to every vertex of the polygon, yeah?
Yeah.
That makes sense?
Yes.
Okay. Now, if you look at this, okay, because the point's not on the angle bisector, it's always on this line is always on one side of the angle bisector, yeah?
Yeah.
So it's gonna make one angle is smaller and the other angle is bigger, yeah? That makes sense? Because it's not on the equal angle thing, yeah?
Mm-hmm.
Yeah.
Yes?
Yes.
Yes.
Okay. Okay, now can you see if I look in this triangle here, it's the same thing happens here. This is like bigger and this is smaller, yeah?
Okay.
Can you see why it can't be smaller and smaller?
Yeah.
Huh?
Yeah, because one has to be smaller than the other.
Because what?
One has to be like one is no. What if they're equal? I thought the red lines were angle bisectors. Are the red lines angle bisectors?
No, they're just joining the points to all the corners. The point doesn't lie on any angle bisectors, remember?
Oh yeah.
Okay, so the angle can't be smaller, because what does it mean to be smaller? It means it's inside the angle bisector, right?
Yeah.
So if it's smaller and smaller, then this point's actually covered by this triangle, yeah?
Why?
Because it's on the same side of both angle bisectors.
Oh yeah.
Okay? So, because we're assuming the point's not covered, right?
Yeah.
Okay. So it has to go smaller, bigger, smaller, bigger, smaller, bigger, yeah? Does that make sense?
Yes.
Okay, next point, okay?
Yeah.
Okay, next point. Okay, so if we have a triangle, if we look at this triangle, okay? Yeah. Then this side here is bigger than that side there because this is a bigger angle and that's a small angle, yeah?
Yes.
So this side is bigger and this one's smaller, yeah? Okay.
Okay.
But if you look at this triangle here, yeah,
Yeah.
then this side is bigger than that side, right?
Yeah.
Yes?
Yes.
And then if you look at this triangle here, this side is bigger than that side, right?
Yes.
Yeah.
Okay. And if you look at this triangle here, right?
Then it just goes into a loop.
This triangle, this side's bigger than that side, right?
Yeah.
Okay, and now if you look at this other triangle here, this one here, right?
That one has to be bigger than the other one.
This
So the
one,
smallest one is bigger than the biggest
the
one.
smallest one is now bigger than the biggest one, which is bigger than itself, right?
Yes.
Oh, great.
And that's a
Shows.
contradiction, yeah?
This just can't happen.
That just reminds me of the staircase.
Yeah.
Lowest one is the top level again.
Okay. So I'm telling you that this proof is wrong, okay? So you gotta tell me what's wrong with it.
There's a lot of contradictions.
Yeah, so there is a contradiction, but it's not coming from this, okay?
The fact like you cannot just miss one point.
No, I already told you that's not the problem, okay?
The bigger greater than the smaller and small square the bigger one.
How are we sure all these triangles go to the same point?
What?
And
No, we drew the lines from the point to the vertices.
I don't know.
Is a contradiction that 1 is greater than 5, but 5 is greater than 1?
What?
Like the greatest bigger than the smallest, and the smallest being greater than biggest? What?
So what did you say?
Was it like a contradiction like of the smallest line being bigger than the greatest line and the greatest line being
Yeah,
bigger?
I mean that's a contradiction. A line can't be shorter than itself, right?
What if they're equal?
Huh?
What if they were equal?
Well, they're not equal. We said that they were each one was bigger, right? Alright, I'll give you like 4 minutes to think of it, and then I'll fix it for you, okay? Did you find the error? Hello? Are you still there?
Yeah.
Yeah.
Did you find the error? Okay, so the error is actually a really obvious one, okay? But you have to be listening very carefully, okay? So this is where a lot of the maths for young kids is not that people don't understand stuff, it's that they think they understand things that are not true, okay? That's like the number one issue in maths quality for young kids. Okay, so here's the issue here, okay? So we said this angle is bigger than this angle, right? Yes?
Yes.
Yeah.
But we didn't say this angle was bigger than this angle, yeah?
Oh.
Oh.
Yes?
Okay.
But I was just very deceptive because I wrote them all as little s and these as big B's. You think the big B's are always bigger than the little s, right?
Yes.
Yeah? So it's all right in front of us, but it can be very tricky, right? Especially if we're in the rhythm of things, and especially if the argument sounds nice, right?
Yeah.
Yeah.
Kind of cool, right?
Oh.
Yeah.
Yeah, so it's kind of maths can be very tricky, but um yeah, well, it's nice to understand stuff. Okay, so how can we fix this argument, okay? So what do we do? So the problem is we don't know this angle. We don't know this angle is actually bigger than this angle, right? You see what I'm saying?
Yes.
But we do know, what we do know is, what we do know is that the angle bisector, okay, um, like if one side is smaller, so the angle bisector actually lies. So if the angle is bigger, the angle bisector is on the inside, right? And if it's smaller, the angle bisector is on the outside.
Yeah.
Does that make sense?
Mm-hmm.
So what that means is it's closer to this side, okay? It's closer to this side than it is to this side, right?
Mm-hmm.
Yeah? So this way we're still working with these angles here now, right?
Yeah.
So that means this distance to the, so we're not talking about the distance to the vertex anymore, we're talking about the distance to the side, yeah?
Mm-hmm.
Yeah.
Yeah, so the distance to the side, so this distance is closer to this side, so it's closer to this side than it is to this side, yeah? That makes sense?
Yeah.
Okay, but in the same situation here, this side is closer to this side than it is to that side, right? That makes sense?
Yeah.
Like it's always on one side of the angle bisector. So it's closer to this side than it is to this side, yeah?
Yeah.
And it's closer to this side than it is to this side, yeah?
Yeah.
But then you go all the way back to the start, then it's actually closer to this side than it is to that side. So then this distance is longer than itself,
Yeah.
yeah?
Yeah.
And that's a contradiction.
Yeah.
So can you see why this argument is actually better? Because it actually uses the distances like in the other argument, right? Because that's what the angle bisector does. So the distance to the sides are getting longer and longer and back around on itself, not the distance to the vertices, okay?
Right.
Um,
I was thinking only some things can be longer than itself.
yeah.
For example, I am longer than myself.
Yeah, you're constantly growing, yeah. Um,
Yeah, I'm still myself.
yeah, like by the time you go around, some time has passed. But here, it's like there's no actual time lapse. Um, yeah. Okay, and then can you see actually what it proves? What it proves is there's no shortest side distance, right? So this is actually like the contrapositive of what we proved before. We basically proved that because there exists a minimum distance, yeah, then the point has to be inside the triangle, some triangle, yeah?
Okay.
Here we're showing if the point's not inside any triangle, then there isn't a minimum distance, right?
Yeah,
Because the distance just keeps getting smaller or bigger, yeah?
it doesn't have a distance.
Yeah, it doesn't have a proper distance. It's not, it doesn't have a smallest distance to any of the sides, or a biggest distance.
It doesn't even have a distance.
Yeah. Well, it has to have a distance, but yeah, like it's contradictory. Yeah. Does that make sense?
Yeah.
Okay, yeah, I guess I was gonna do a bit more with this Russian thing, but we ran out of time. But yeah, which questions haven't we done now? All right. Okay, so are there any questions about this?
No.
All right.